Hi everyone, welcome to CHM 5403 Biosensor Technology. In this video, I'm going to talk about the immobilization techniques of DNA probes on biosensor. The main techniques involve adsorption, covalent bonding, the use of polymer, self-assembler monolayer, biotinylated DNA, and nanoparticles. Adsorption is the most simplest technique as it does not require the use of any chemical reagents or the modification of DNA probes. The mechanism involves electrostatic adsorption, whereby the negatively charged phosphate group of DNA will be attracted to the positively charged of the modified electrode. However, there are some limitations for this technique, whereby the pH, ionic strength, and temperature of the condition can cause the instability of the adsorption, and the irregular orientation of DNA probes on the electrodes is not stable. Covalent bonding provides the better stability, flexibility, and higher binding strength of the immobilization process. The good vertical orientation of DNA probes on the surface provides better efficiency of DNA hybridization. Furthermore, it can prevent the non-specific binding of other foreign molecules. In covalent bonding process, the DNA probe is normally linked with thiol groups and amine groups, and they are bind covalently to the metal surface or specific functional group that is introduced to the electrode surface. Polymer is any of a class of natural or synthetic substances composed of very large molecules that are multiples of simpler chemical units. One of the examples of polymer is paired PSS, which is abundant of carboxyl group. These functional groups can be bound covalently to amine groups of DNA probe. The electrostatic interaction also plays an important role, whereby the NH3 of chitosome polymer can be binded to the negatively charged phosphate group of DNA probe. Polypyrrole, polyl-lysine, polyethylene-imine, and polyaniline are the other examples of polymers. Biotinylated DNA is highly stable, resistant against temperature, organic solvents, and pH. By modifying the surface of the electrode with molecules such as avidine and streptavidine, the biotinylated DNA can be bound onto the surface. The working electrodes such as carbon, ITO glass, or gold surface can be functionalized with the gold nanoparticles, promoting the immobilization through the strong affinity of gold and sulfur interaction. With this technique, the electrochemical signal can be amplified due to the increased surface area of electrode, which is attributed to these nanoparticles. Same goes to self-assembler monolayer, which are molecular assemblies formed spontaneously on surfaces by adsorption and are organized into more or less large ordered domains. Similar to the gold particle, whereby the strong affinity interaction between the gold and the thiol group promoting the self-assembly of thiol-modified DNA probes on the gold surface. This technique provides strong binding strength, easy preparation, and is highly reproducible. In conclusion, all techniques have their pros and cons. The suitable techniques should be effectively irreversible over the life of the sensor and limits the non-specific binding. In order to select the suitable immobilization technique, following criteria should be taken into consideration, such as nature of the solid substrate, solution conditions, and the probe properties. That's all for this topic. Thank you for watching.